Methodologies. A software/system development lifecycle is essentially a series of stages that provide a model for the development and management of a piece of software. It is independent of the development methodology used. There are just 5 basic methodologies and 2 approaches. The 2 approaches are linear or evolutionary. Linear. A linear approach describes a sequence of tasks that are completed in order, only moving to the next step once the previous step is complete. This is suitable for developing where the requirements are well understood, can be agreed upon upfront and are unlikely to change. Strengths. Manageability and cost. Breaks down problems into distinct stages, all issues are captured and corrected before the next step starts. The locking down of each stage before advancing to the next makes it easier to control cost and scope creep. Simple development. Everything is agreed in advance of being used with no need to revisit later. Weaknesses. Rigid structure. It doesn't cope well with changing requirements. And each stage must be done properly as it is hard or impossible to go back and change it later. Time and value. For large projects, the time required to be thorough at each stage leads to long timescales. If the project is stopped before completion, there will be little or no business value to show for the cost. Evolutionary. An evolutionary approach evolves the solution through progressive versions, each more complete than the last. The evolutionary approach is the basis of agile development methodologies, as it focuses on progressing understanding through delivering early prototypes or iteration releases. It assumes that requirements are not well understood or cannot be well articulated early in the life cycle, or that early delivery is more important than completeness. Strengths. Early benefits. Early delivery of value to the customer either through working versions or knowledge of project risk. Flexibility. Copes well with complex requirements especially if they are yet to be defined, fast-changing, or complicated. Allows collaboration between the user throughout development. Weaknesses. Over/under predictions. Easy to overpromise on early functionality. Overall costs can be higher due to the evolving requirements, meaning it can be hard to give a definitive cost of a project. Management. Careful management required, as it can be hard due to multiple iterations and especially so with multiple iteration teams or complex products. The 5 basic methodologies are: Waterfall, V-model, Incremental, Iterative, Spiral. Methodologies based on the linear approach. There are 3 methodologies that follow the linear approach: Waterfall, V-model, Incremental. The waterfall method. The waterfall method dictates that each step should be completed before moving on to the next step. This results in a quality product as the system is well understood through formal documentation and review. The dotted arrows show that if a problem occurs in any of the steps, then communication and understanding must also flow backwards to rectify the problem. For example, if during development a problem occurred where a particular requirement could not be satisfied, then development would stop whilst the design step was reconsidered in light of the problem and, if necessary, the requirements engineering stage would also be revisited. Strengths. Simple. Simple to understand and easy to use. Ideal for solid understanding projects. Good for developing systems where the requirements are well understood and unlikely to change. Easy project management. Due to the rigor and control around each stage, with obvious hooks for project milestones. Weaknesses. Rigid structure. Once the requirements stage is complete, changes become increasingly expensive, as the team must revisit the requirements stage and all stages afterwards. Formal change control procedures are often put in place to manage change or even prevent the changes. Deliverability. Working software not delivered until the final stage. User input limits. Customer collaboration is limited to requirements and user testing. Cost. Poor estimation can severely impact project cost and schedules, and change can be expensive. The V-model. The V model was introduced as a solution to the Waterfall model's time for testing issue, whereby time allocated to testing could often get squeezed during a project if time and money started to run out. The V model, also known as verification and validation model, is an SDLC model where execution of processes happens in a sequential manner in a V shape. For every phase in the development cycle, there is a directly associated testing phase. The extended V model, illustrated above, introduced the feasibility and benefits realization stages, as a way of measuring and testing how well the actual business benefits were delivered, as opposed to testing when the requirements were delivered, as a system could verify and validate all the requirements, and yet fail to meet the need of the business because it does not deliver the business benefit. In software development, validation is the process of checking the accuracy of developed components against a specification. In layman's terms, it is looking at the specification that says what the system should do, and looking at the components being developed, and checking if it will perform a function related to the specification to satisfy or fit the user requirements. Validation can be done at any stage in the SDLC, however the V model dictates that it should be done in a sequential manner. There are two types of validation, internal and external. During internal validation, it is assumed that the goals of the stakeholders were correctly understood and expressed in the requirement artifacts, and so if the software meets the requirement specification, it has been internally validated. External validation is performed by asking the stakeholders if the software meets their needs. If it does, it is successfully externally validated. Final external validation of a project requires the use of an acceptance test, which is the last validation testing phase in a standard V model, and the second to last phase in the extended V model above. Verification is testing code, and it can only be done by developers or testers. It must be someone who understands code. It is looking at the components and testing to see if it does what it should do. Validation vs verification summary. Validation is the process of evaluating software during, or at the end of development, dependent on the development model, to determine whether it satisfies specified requirements, whilst verification is the process of evaluating software to determine whether the components of a given development phase satisfy the conditions imposed at the start of said phase. Strengths. High-quality product. Due to the additional focus on testing, great for safety-critical systems. Easy to manage. Due to the rigid structure and control. Weaknesses. Cost. For simpler projects, the heavy testing and integration cost can be unnecessary. Cost and impact of change increases significantly as you progress further down and up the model. Time. Early stages take longer to complete as there are test artifacts to create. Deliverables. Working system not delivered until the final stage. Equal importance. Development teams can often omit putting enough effort into planning the right-hand side as they progress down the left, which results in significantly increased risk. Incremental life cycle. The first three stages of the SDLC are conducted in sequential order, each being completed before the next is started. However, where the incremental cycle differs from the waterfall or V model is that after understanding and designing the system, decisions can then be made to deliver some parts of the system before others. The incremental life cycle, also known as instrumental delivery, is ideal where early capability is required, as high priority requirements can be delivered first. Strengths. Cost. If the business decides that the delivered functionality of the earlier increments is sufficient, then the project can be stopped and no further cost is incurred. Deliverables. Delivers working software early on. Weaknesses. Cost. Additional releases add to costs, as release costs such as user training and deployment are incurred multiple times. Subsequent releases must be regression tested also, against earlier functionality, meaning that features in the first release are retested in every subsequent release to ensure that they still work properly, which adds to the test cost. Change management. Difficult to manage change, as requirements are agreed before increments decided.